Good morning to everyone. In this lecture, we are going to study about thermoplastic polymers. In general, polymers are classified into two categories: natural polymers, synthetic polymers. In general, polymers are very large molecules size. They have macromolecules which are multiples of simple chemical units. The simple chemical units are called as monomers or mers. So, examples for natural polymers are proteins or cellulose. Examples for synthetic polymers are hydrocarbons such as ethylene, propylene, vinyl chloride are acting as monomers and they combine to form the polyethylene, polypropylene or polyvinyl chloride. There are two types of thermoplastic polymers, synthetic polymers, thermoplastic polymers and thermosetting polymers. Let us differentiate thermoplastic polymers and thermosetting polymers. The examples for thermoplastic polymers are PVC, polyethylene and polystyrene are the examples for thermoplastics, and polyurea formaldehyde, phenol formaldehyde are the examples for thermosetting polymers. Thermoplastic polymers are formed by additional polymerization, whereas thermosetting polymers are formed by condensation polymerization. Thermoplastic polymers are softens when heat is applied and harden when cooled. But thermosetting polymers are permanently hard when heat is applied and do not soften upon subsequent cooling. Once it was set and it will not regain its original shape. Thermoplastic polymers can be remolded and reshaped, whereas thermosetting polymers cannot be remolded or reshaped. Thermoplastic polymers possess higher ductility and are not harder and stronger, whereas thermosetting polymers possess poor ductility but are stronger and harder. Thermoplastic polymers are long chain, straight or branched molecules, whereas thermosetting polymers have similar structure as thermoplastics before heating, but cross-linking occurs during heating and it becomes hard and it results in three-dimensional giant molecule. Thermoplastic polymers possess greater impact strength, whereas thermosetting polymers possess less impact strength. In this lecture, we are going to study about thermoplastic polymers: PP, polypropylene, PS, polystyrene, PVC, polyvinyl chloride, PMMA, polymethyl methacrylate, PET, polyethylene terephthalate, PC, polycarbonate, PA, polyamide, ABS, acrylonitrile butadiene styrene, polyimides, PI, polyamide imide, PAI, PPO, polyphenylene oxide, PPS, polyphenylene sulfide, PEEK, polyether ether ketone, PTFE, polytetrafluoroethylene. Thermosetting polymers are urea formaldehyde and phenol formaldehyde. Phenol formaldehyde is bakelite, which is used as electric switches and fuses for electric switches. First one, thermoplastic polymers, polypropylene. It is one of the world's major plastics. The monomer is propylene and it is a byproduct from gasoline refineries. Polymerization is carried out using famous Ziegler-Natta catalyst. The propylene, it has a structure C3H6, CH3. It is a monomer and it is a repeating unit, and it is multiplied 10,000 times or 50,000 times to obtain the original polymer. So C structure is CH2 and CH3, C3H6. Properties of polypropylene. Polypropylene is highly crystalline, similar to that of metals, and it exhibits higher stiffness and hardness, tensile strength even at elevated temperatures. Polypropylene have high strength to weight ratio, make it very useful in industrially. It has a melting point more than 100 degrees Celsius. It is insoluble to many solvents and it has resistance to many chemicals such as acids, alkalis and oils. It is relatively inexpensive and it has poor resistance to ultraviolet. Applications of polypropylene. Polypropylene components are used in making refrigerators, radios, TV cabinets and luggage and suitcases can be made using polypropylene. It is also used for producing package films, pipes, storage tanks, seat covers and ropes. It is also used to make automobile components, medical devices, wire insulation, drinking cups, dairy products, juice containers, etc. Second polymer, polystyrene. Polystyrene is also known as polyvinyl benzene. Polymerization of styrene was accidentally observed in 1839, but it was not commercialized until 1930 and it was commercialized around 1930. It has a structure of CH instead of CH3 in polypropylene. It has a benzene molecule. So it has a C2H3 and a benzene structure. It is a monomer. It has the repeating units of this monomer will produce polystyrene. Polystyrene is produced from ethylene and benzene. When ethylene is passed into benzene in the presence of aluminum trichloride catalyst, ethyl benzyl is produced. When ethylene is passed over a catalyst such as iron oxide or magnesium oxide, it is converted into styrene and hydrogen. Okay. Ethylene plus benzene gives ethyl benzyl. Ethyl benzyl gives styrene and hydrogen. Styrene is a monomer and is industrially produced by free radical polymerization. Properties of polystyrene. Polystyrene is a linear polymer and it is amorphous. Polystyrene is outstandingly easy to process. Its stability and flow under injection molding conditions make it as ideal polymer for injection molding techniques. Polymers, plastics can be injection molded. Polystyrene plastics can be injection molded because of this property. Polystyrene has good color and clarity and has a refractory index of 1.60. Its optical properties make it useful for optical components. Optical components can be made using polystyrene. Polystyrene is a good electric insulator and has a low dielectric loss factor. It is relatively inexpensive and resistant to acids, alkalis and oxidizing and reducing agents. Applications of polystyrene. Polystyrene is used in the manufacture of containers, lids, jars, bottles, radio and television cabinets, toys and household items. And acrylonitrile butadiene styrene ABS is a copolymer of polystyrene and is a commercial plastic which is used to make household items and packaging containers. Styrene acrylonitrile SAN is a copolymer of polystyrene which has good impact strength and is used to make machine components. Polystyrene is used to make battery cases, door lighting panels and optical components because it possesses good optical properties. The third synthetic polymer is polyvinyl chloride. The monomer of PVC is vinyl chloride. Vinyl chloride is a gas and it has a boiling point of minus 14 degrees Celsius. Since the monomer is a gas, the polymerization is carried out in a pressure reactor. Suspension polymerization technique is used for the production of polyvinyl chloride. The structure of polyvinyl chloride is very important and in every polymers the structure is very important. It is CHH and CH instead of CH3 in the polypropylene, chlorine atom is present. Okay, it has a structure of CHH, CH instead of CH3, Cl and it is a monomer and the end time of this monomer will give polyvinyl chloride. There are two methods of producing PVC. First method, one by cracking ethylene dichloride. Ethylene dichloride is CH2Cl, CH2Cl. In the presence of pressure and 500 degrees Celsius, it can be cracked down into vinyl chloride CH2 CHCl plus hydrochloric acid. Another second method is reacting acetylene C2H2 with hydrogen chloride HCl in the presence of catalyst and it gives CH2 Cl. It is a vinyl chloride. Vinyl chloride is produced. Azo compounds are used as initiators in suspension polymerization. Properties of polyvinyl chloride. The total chlorine content in PVC is around 56% and can be further increased to 65% by dissolving it in a suitable solvent. The polymer is thus formed is a chlorinated PVC. The principal advantage of chlorination is that polymer becomes more resistant to acids and bases. PVC is insoluble in alcohols, water, hydrocarbons and vinyl chloride. Copolymers of PVC containing 10% vinylidene chloride have better tensile properties than pure polyvinyl chloride. PVC has low crystallinity and have a complete regular structure. PVC is relatively unstable to heat and light. PVC is thermally not stable beyond 200 degrees Celsius and it degrades with the addition of HCl and decolorization of polymer will occur when it is exposed to light for a long time. To avoid decolorization, suitable stabilizers such as amine and epoxy compounds are added. The processing of PVC is very difficult and hence plasticizers are added. PVC is one of the cheapest and most widely used plastics globally. Applications of polyvinyl chloride. The largest use of PVC is the production of pipes, which accounts for 40% of production. The PVC pipes are used for water supply and distribution, agricultural irrigation, chemical processing, drain waste, vent pipes, sewer systems pipes, conduits for electrical and telephone cables. Second application, the building construction market accounts for 30% of PVC production, including window frames, wire and cable insulations, wall coverings, gaskets, interior moldings, etc. Automotive uses, footwear, sporting goods and toys, bottles, meat and food packaging, etc. are made out using PVC. PVC is used for the large-scale production of cable insulations, equipment parts, laminated materials and in fiber manufacture. The main use of chlorinated PVC is in the manufacture of adhesives, coatings and fibers. The fourth synthetic polymer is polymethyl meth acrylate, PMMA, polymethyl meth acrylate. Monomer PMMA is methyl meth acrylate. Methyl meth acrylate is produced from acetone. PMA is produced by radical polymerization. It has a structure of CHH, CH3, COO, CH3. CHH, CH3, COO, CH3. N times of this polymer give PMMA. It is produced from acetone by heating acetone. Heating CH3COCH3 is heating the presence of hydrogen cyanide to form acetone cyanohydrine. So acetone cyanohydrine in the presence of heated with sulfuric acid at 150 degrees Celsius to form methacrylamide sulfate, and this compound is reacted with water and methanol to give methyl meth acrylate, and SO4 is the remaining product. Properties of PMMA. PMMA is a clear, colorless, transparent plastics with an excellent outdoor life period and good strength. Optical clarity and lack of color is a main feature of PMMA. Its optical properties make it useful for applications where light transmission is important. It is an excellent substitute for glass. However, it has poor scratch resistance compared to glass. PMMA has better mechanical and thermal properties. Electrical properties are also good but not outstanding. It is resistant to many chemicals but soluble to organic solvents such as ketones and chlorinated hydrocarbons. The fabrication of PMMA is quite good. Applications of PMMA. PMMA is used to make lenses, transparent aircraft enclosures, drafting equipments, attractive outdoor signboards and durable lenses for automatic lighting. PMMA acrylic sheets are used for aircraft windows, furniture, partitions, optical components, reflective devices and furnishings. PMMA is also used in buildings for decorative purposes. Thank you.